Here we'll see the UML package diagram and UML structural diagram. So let's see how the package diagrams look like. So package is nothing but it is acting as a container to organize the elements which are present in the system in a more meaningful way and in a concise manner. And the order of the subsystems which are present in the packages must have the cohesive unit. That nothing but the arrangement of the units should be related to each other. So package means it is a building block of the package diagram that is called as package. It is a one of the container where it organizing the different diagram elements. The elements can be classes or interfaces, or it can be any subsystems which are present in the package. So it is usually the representation of the package diagram is folder like icon with its name. That means every package must have a name. The package is nothing but the organization of the folder where each folder contains multiple files. So the general structure of the package looks like this. The rectangular contains acting as a container where it contains multiple elements of different types, classes, interfaces or subtypes. And the top left corner, this is very much important. That is the indication of the package diagram where there is a space provided to write the name of the package name here. And this is acting as package container. So there is a name space provided to write the name of the package. Just now we have seen in the diagram. So it generally appears on the top of the package symbol. So that should be uniquely identifying the packages in the multiple package diagrams. So how can we merge the different types of packages? It can be done. So there is a relationship that signifies how package can be merged, or it can be combined, or it can be joined. So it can be represented using direct arrow between the two packages. That signifies the content of one package can be merged with the content of the another. That is nothing but the package merge. Package import. So it is nothing but we are trying to access the content of the different packages. So it is represented with dashed arrow. So that means we are able to provide the relationship between the two different packages. That relationship must indicate are we importing, or whether those packages we are trying to show the dependency, or do we have any other type of accessibility, or do we have any hold on other packages. In what way we are trying to show the association between the multiple different package diagrams. So if it is a dependency, changing anything in one package, definitely it is going to affect on the other package. So that is nothing but a dependency. So before changing any content in one of the package diagrams, we must sure is there the subsystems have high coupling or it is a low coupling. High coupling means immediate effect on the other content of the package diagram, and if it is a low content means low coupling means there will not be much affected, the content will be much affected. So elements in the sense an element can be a single unit, can be inside the packages. So there can be a single or it can be a multiple. So all different types we call it as elements. This can be a classes or interfaces, or it can be subsystems. So there can be some constraint. Based on the constraint, the content can be formed together in a single package diagrams. So content usually will be written like a curly braces. So this is the diagram, just the general representation of the package diagram where the package contains multiple elements, where the top corner indicates the name of the packages which is uniquely identified. And if the package contains multiple subsystems, on what subsystems the elements we have grouped together, that condition need to be written here with this symbol. So dependency and the import. So how we can able to differentiate the dependency and the import between the two different packages. So there is a fish and water, right? So fish will be there if there is only the water. That means the fish is depending on the water. So the dashed arrow indicates the dependency among two different elements, or it can be a same element of the packages. What do you mean by the import? So here in the import, here also we are using the dashed line between the Java and util.vector. There are two different packages. So what content we are trying to import from one package to the another package? That is nothing but the import. So on the dashed arrow, we have to write within the this symbol whether are we trying to connect with the import or accessibility for what with respect to what. So here we are trying to enable or we are trying to access the data which is related, that is from the Java we are trying to we are trying to gather into the another package diagrams. So what do you mean by merge? So as we said already, merging means the content of one package can be merged with the another because multiple association between the two packages are showing with the dashed arrow. So are we merging or are we trying to show the dependency or are we accessing any information which is publicly available from one package to the another packages? So it's a package merge relationship. So this relationship is used to represent the content of the package can be merged with the content of the another. So here cash payment, online payment, card payment and check payment. These are the different types of different packages, but all are with respect to the payment. So we are trying to combine or merge all the different packages into trying to give a single, or we are trying to combine and merge. We are trying to reduce the complexity of the diagram here, and we made it as a payment because all other the sub packages are related to the payment. So package dependency relationship and import relationship. So just now we have discussed. So in what way we are trying to show the relationship between the two different packages here. So online payment and the internet. So how the dependency here? So if you want to do the online payment, we need internet. If there is no internet, we cannot do. That is what the dependency on one another. So package import relationship. Here we are trying to import few of the shapes from the packages. So it can be a shape, can be a square, rectangle, circle or trapezoid. So which type of shapes we are trying to import? So that is nothing but we are trying to import only the some part of the data from the other packages. That is nothing but the package import relationship. So package access relationship. So it is also a type of relationship. So there is an access relationship between the two or more packages. One package can access the content of another package without importing it. So without importing, we are able to access few part of the data from the front end to the back end. So if we want to access any data from the server, we have to submit the request through the front end and there is accessibility. We are able to fetch data from the back end. That is nothing but the server. So what do you mean by the composite structures? So it is one of the UML structural diagram that provides the overall logical view of the software systems. So it is look like the structure or the composite structure. The structure contain different varieties of the subsystems along with different configurations. So it can be a class or it can be interfaces or different type of packages or different varieties of the relationship may exist between the micro level or it can be the macro levels. So all together will be present within a single structure. That is nothing but the composite structures. So here we have, so if you take the motherboard, so again at the micro level, we are going to differentiate what all the elements or the component which are present okay on the motherboard. And here input and output. So what type of ports are available for the input and output in order to access it. And here the network interfaces. So how we are going to access the internet? It sometimes okay through the Wi-Fi or sometime okay we are accessing okay, through the hotspot or by collecting the Ethernet. So varieties. So we are going to elaborate in the micro level. So all the configurations, everything which is mentioned within the single packages, that is nothing but a composite structures. So different components which are used in the structure diagram, those are the terminator, the symbol. This oval shape indicates the terminator. It can be a start or it can be endpoint, which we have studied in the flow chart of the any programs. And it is a circle where it represents a type of node. it will be contained usually the numbers within the circle. And rectangle, it represents some events. Again, it may contain few numbers. And this is the symbol indicates the actor, where the actor can interact with the system from the outside of the system. So it can be a person, or it can be any equipment. It can be anything which we are connected externally from the system to somebody. So we call it as actor. So there is a class. The class diagram already we have discussed, okay, in the previous session. The name of the class followed by the attribute and followed by the methods. All together form a rectangle box, has three components. We call it as classes. And here colon colon followed by the name of the class. That means here which object we are talking about. Which object is related to the particular class can be accessed with the help of the colon. So sometimes we call it as the instance of the class. This is the object which is related to the main class. So here gives the clarity about the package diagram and composite. So there are a few the symbols which are different here. Here in the network interface, we have a different varieties of the network, along with the different port number will be different. So it is acting as a port that provides the interaction between the system and the outside environment. And here it is interface. So specifies behavior that implements or agrees to meet that particular specific component. And here the solid line which acting as a connector between the different part of the system. So this is about the UML, the structure, the composite structure and the package diagram discussion.